Hello, my name is Glenn Drover. I'm based in Melbourne, Australia. I'm Secretary of the Australian Institute of Energy Victoria branch. I'm also Secretary of the Yarra Energy Foundation, but this presentation is my perceptions, none of those. This is a not very short presentation on AEMO's Q2 of 2023 Quarterly Dynamic Report, and about 40 pages, so a little while. I think the AEMO Quarterly Dynamics reports are excellent reports, contain a lot of data, give us a lot of insights into what's actually happening in the NEM market and some of the outside of the NEM. This is for Q2 2023, and most of what it does is compare to the same quarter 1 year ago, so Q2 of 2022. The figure numbers for each of the slides, I've left those on, so you can directly reference those back to the detailed written report. But hopefully this video summary will help you if you don't have time to read right through that report. We've had a lot more growth in renewable energy, and in particular in behind-the-meter PV. And so with additional behind-the-meter PV, of course, it reduces the operational demand that AEMO sees from in front of the meter. And so quite a significant change over the last 12 months. And as you'll see here in the middle of the day, around about a 1200 megawatt reduction in middle of the day operational demand, so quite significant in just a 12-month period. The growth in PV was correspondingly quite large. It's the second highest growth they've had in the 12-month period. So year on year, a 30% increase in the amount of PV output compared to 1 year ago. The behind-the-meter PV, of course, is still growing very strongly, and it's been aided by recent increases in retail charges, which makes more and more people have a look at their bill and consider the option of adding some solar on their roof, which is so easy to do these days. There was a welcome reduction in the spot dispatch prices, particularly to 12 months ago. So that Q2 2022 last year was the beginning of a pretty problematic period for the NEM. And you remember I actually brought a stop in the market operation for a period of time while AEMO sorted out a number of things. So comparisons to that Q2 2022 last year do have to take into account that that was not quite a normal quarter. And so you'll see the average NEM spot prices for that quarter were particularly nasty, up almost to $300 for the average for the 90 days. And the quarter after that was not much better. And you'll see that now the prices have come back down to that sort of $75 mark, much more in line with what we normally see, and particularly in that second quarter of the year. So good to see the prices coming down. That, of course, will be reflected in retail prices and forward prices. So it's nice to see a drop again in those prices. This is an interesting chart because it's a measure of something, but it's not actually a real thing. So what they've done is they calculate what the cap cost, the returns would be if you had a cap for all of the times that the price was over the $300, for which there's typically caps in the market. So it's probably better just to look at it as a measure of the volatility of the market. And so those hashed areas there give you an idea of how often the market was over $300 in each of those periods. And so that the red maroon colour is that troubled quarter of Q2 2022. And so you'll see that the effective cap cost or cap return value in those quarters was quite bad. But now into the quarter we've just had, the cap returns are much, much lower, as you'll see here and here and here. And in fact, in Victoria and Tasmania, cap returns don't show up on the chart. So mainly a measure of volatility, showing us that the volatility fell significantly, and not too many periods in excess of $300. This is a really interesting chart. It's averages, and so as always, you need to be aware of averages. But what it's showing you is for each of the time periods over a 24-hour day, the 90 days of the price for dispatch price for that particular period of time, and averaging out 90 numbers. So it hides a lot of detail, of course, as an average, but it's interesting to look at as a trend. A couple of observations. One is our current quarter that we're looking at is the teal colour, and you'll see how low it went during the middle of the day. So down to around about $30 a megawatt hour. And why that's interesting is not so much that it went down in the middle of the day as there was excess solar, but that the period during the night, which is when things like the off-peak electric hot water cut in, was actually higher than it was in the middle of the day. So a number of you that know me know that one of my projects I often ask about is why aren't we moving the middle of the night off-peak hot water heating to during the middle of the day? And a lot of discussion on that, lots of people talking about it, and great report came out of UTS this year, which looked at the opportunities there. It is a significant amount of energy, both in demand and power. And so around about 10 gigawatt of those electric storage heater elements in the NEM, and about 25 gigawatt hours a day of energy. So there's an opportunity there, and I'm sure it will be taken up as it becomes applicable. Interestingly, that 10 gigawatt, 25 gigawatt an hour, how will it change as we go forward? Well, with the movement of gas to electricity, electrification of homes, the electricity demand for electric hot water will, of course, increase. But we also have a lot of people who are moving from existing electric direct element hot water heaters, and that's what most of that 10 gigawatt is. A lot of people are moving to electric heat pump hot water heaters, which of course will drop their demand down by anything up to about 2/3. And so some changes will be increasing the electrical energy required for off-peak hot water heating, and then other things are reducing. But certainly a really good area to watch in the future. We had a big coal exit over the last 12-month period, but interestingly, over the last quarter, there was actually more coal generation being offered into the NEM spot market, not less than 1 year ago. So what this chart shows is the amount of megawatts on the horizontal and the price that those megawatts were offered into the market, into the dispatch engine. And so what you see is this sort of 9,500 to 10,000 megawatts worth of black coal that was offered into the market increased to around the 11,000 megawatt point as an average in that quarter of the, and at around about the same prices as it was. So significant increase in what was available. And of course, as it's right. And again, coming back to prices over $300 a megawatt hour, as I said in the earlier chart that showed the caps, they were less frequent. And so the calculated cap returns were also lower. And so this indicates what cap returns would be on those caps, typically $300 per megawatt hour caps, and it shows a sharp drop in those cap returns. This isn't telling you exactly what the retailers were faced with. So retailers would have their individual cap books, and so it's not telling you what those books look like or the costs in those books. What it's giving you is an idea of the volatility and the number of caps that may have been in play. Again, this slide highlights again that there was a low volatility in the recent quarter compared to that wild ride that we had in Q2 of 2022. So the period, the percentage of the time that the prices were over $300, which is typically when those caps cut in. You see Queensland only around about 3%, New South Wales even less, Victoria similar, South Australia a bit higher, up around 8%, and Tasmania way down there, only around about 1%. Did the market exceed that $300 cap? There were record high negative dispatch prices, and these always get a lot of headlines. So people look at the amount of time that the market is negative, but remember, people are looking at the dispatch engine, the NEM spot price, which is a dispatch engine, which is being used to determine who is the last generator in, who is the last generator that comes online to meet the physical number of megawatts demand that are there in the NEM. It's not reflective perfectly of the actual prices that the retailers pay the generators for that electricity. And to give you an example, the NEM effectively is a dispatch engine for a total of around about 200 terawatt hours of energy per year in the NEM. But if you go to the hedge markets and add up all of the hedges that are traded over a 12-month period, over the last 5 years, that has varied from about 700 terawatt hours up to about 1,100 terawatt hours. In other words, 3.5 to 5.5 times the actual amount of energy that's actually produced and used in the market. So they are indicative, and so these record high negative price periods and the amount that they're negative, they do get reflected in the futures prices, but you do have to be careful when you look at them and when people write them up in articles. Quite often there's some confusion there. So as is normal, 16% of the time was the energy price, was actual spot price was negative in South Australia and lower amounts in the other states. Interestingly, Victoria jumped up quite a bit in this quarter compared to quarter 2 of 2022. So, and Queensland, which you'll see in another chart coming up, which highlights the increased amount of PV, solar in Queensland. This chart, as I mentioned, highlights just for Queensland and looks at its negative prices. Negative prices, not surprisingly, occurring in the middle of the day, so that's when we have excess solar, and Queensland has added a lot more solar to its grid, both behind the meter and in front of the meter, over the last 12-month period. So what it's telling you is that for up to 50% of the dispatch price periods in that very middle of the day period were negative in Queensland. So very significant compared to only a year ago, down at 10%. But again, as I say, these are dispatch spot prices, and you have to also look at the real market trends and the real prices, which are hard because they're in hedges which aren't public domain. In South Australia, not only were there more negative dispatch prices, but also they were more negative, a bigger negative number than they were in quarter 2 of 2022. So jumping straight to the big one in the middle here, the price band of -$40 to -$60 per megawatt hour, which was only about 4% of the time in a year ago, this time reached 8% of the time that of the quarter where the price was in that negative band. So quite a significant jump, and something that a lot of people will be following to understand. As I mentioned, there was more coal available in the market than there was last year in quarter 2 2022, and so that meant that coal set the final generator in, so the final dispatch price, more often than it did in the quarter before. So in particular, if you jump to New South Wales, to the black coal, you'll see that the black coal in this quarter set the price around about 40% of the time, whereas a year ago it only set the price about 30% of the time. So a bit of an increase there, and impacted on the amount of time that the hydro was setting the price, which is quite common. The more bidding, more bids that are lower, leads to less volatility, and that means that the last generator in, the one that's setting the price, the prices tend to fall. And so this is quite significant between that quarter a year ago and this quarter. Average price that coal set when it was the price setter, so not all of the time, but when it was the last generator in, huge drop from $250 down to $100. And hydro similarly from $300 down to $150. So gives you a good indication of what's been happening in the market in that period. I mentioned that you do see the impacts of those negative price periods. They do give a signal to the market, to the generators and the retailers, and they give them a feel for what sort of prices they should be paying for in their hedges. And this is the futures market, which is only a small percentage of the hedges that are out there. But it does give people an indication of what the generators and retailers are thinking and doing. And you'll see there that for the 6 months, sort of the first half of this year, 2023, those hedges for those futures are sort of rolling along in that $80 to $150 period. So it just gives us a bit of an idea as to what influence the negative prices and indeed the spikes in the prices are having in the futures contracts. The change at the very beginning of the presentation, we looked at the change in generation, how much additional generation was coming from renewables. And this is a nice way of actually representing that to give you an idea. What it's telling you is that solar distributed and grid solar each picked up around the 400 megawatts of additional average output over the quarter compared to a year before, and wind similarly around about 400 megawatts. Interestingly, brown coal picked up a small amount. And the big reductions compared to 1 year ago, which is this chart on the bottom, is in gas and in hydro. And of course, that represents the fact that that was that problem quarter. And during that problem quarter, gas and hydro were indeed supporting the market and keeping the market going when there was a significant number of coal outages in that period. So it's just a nice way to look and see what the change has been over 12 months. And if you take that instead of just being the average, but looking at the average for each of the time periods over the day, again, it's just an average, so be careful, but this is effectively the 90 days of averages for each time period during the day. And you can see quite quickly, it shows the big reduction that occurred in gas in this quarter, big reduction in black coal, that little increase there that came out of brown coal, but big increases in solar in both grid and in rooftop PV behind the meter. The additional solar, of course, is having an impact on the coal generators, both black and brown. And this shows you the average black coal duck curve that we're all familiar with. It came down another 1,000 megawatts in the last year. So quite a significant jump from 2022 there down to where it's reached to this average of about 7,500 at the low point in the middle of the day each day. But if you go back 3 years to Q2 2020, you'll see that overall it's dropped 2,500 megawatts in the middle of the day. So very significant decline, not quite as dramatic as the chart looks because the bottom of the y-axis there is at 7,000 megawatts. But nonetheless, this is significant and of course increasing over time. One of the other areas that impacted the market a year ago was the significant number of unplanned brown coal outages in Victoria. And you'll see how significant here with almost 1,000 megawatts on average over the 90 days of unplanned brown coal outages. So that certainly didn't help the volatile market that we had last year. And you'll see that that has now significantly improved over the last 12 months, where the average megawatts for unplanned brown coal outages is only around about 300 megawatts, so only about a third of what it was a year ago. Interestingly, you'll see significant increase in planned outages. so doing maintenance, etc. The brown coal plants have also got their own duck curve. I've called it here the Victorian brown duck curve. It's nowhere near as significant as the black coal for New South Wales and Queensland. Again, the axis here, the vertical axis, starts at 3,400, so it's nowhere near as dramatic as what the curve shows. But nonetheless, it has dropped from 4,000 down to just under 3,500 over the last 3 years. So only about a 500 megawatt, less than 10% impact on the middle of the day on the brown coal. It tends to just bid in so low that it just manages to stay in there. And it can also withstand negative price periods to a large extent because of its forward hedge contracts, which means that it's not necessarily impacted very much by negative prices in the middle of the day. And you see the difference over that 3-year period, which I mentioned before. As the renewable share rises, some people say, well, as renewables increases, so will the use of gas. It's certainly not happening yet, and you wouldn't expect it to, whilst we've got that black coal and brown coal ramping up and down to help meet the difference. So as you can see here, there's a trend from sort of that high in 2012, 2013. The amount of gas, looking at all the states here together in the NEM, is fallen quite considerably, down to about half compared to that peak back in 2014. So at the moment, gas for electricity is continuing to fall. We would like to see that continue to happen. The question is, will it do so as more and more coal plants shut down? So again, an area that everybody watches. Earlier, I showed the gas, the black coal offers in the NEM, and this is the same chart again, but this one is for gas. Gas did the opposite though. Whereas black coal has significantly increased its offers over that 12-month difference, gas reduced. Again, a little bit confusing because of the scale on the chart, that the bottom marker here is 1,000. But what you'll see is gas reduced its offers into the NEM about 500 megawatts from typically 1,500 plus megawatts down to about 1,000 megawatts. So about a 1/3 reduction, but at the similar prices that it had offered the year before. And to complete the picture there, the other major offer into the NEM, particularly for setting the price, last generator in, is the hydro. And you see that the hydro did increase its offers a little bit, around about 500 megawatts, so about 15% extra offer into the market. Very similar prices, so not much difference, not much vertical gap between the two curves, but a little bit more was offered than was offered in the quarter last year. The increases that we saw in some of the earlier slides, in particular, highlight the additional amount of new PV in the market, both rooftop and grid. This is looking at the grid, the solar farm, so looking at the grid solar, and it shows us what's made up that average output increase for that quarter, an additional 350 megawatts, so quite significant. And it shows where that's coming from. So plants not only finished new capacity, but also some being commissioned. What's great is this chart also includes this curtailment here, and it's really nice to see a small number of only 8 megawatts average curtailment on the solar farms. And then you'll see this other number here, the 38, the offloading. So this is where the actual owner of the solar farm has offloaded the solar farm because of negative prices. What it tells you is that that solar farm is probably running some of its megawatts merchant into the market, so it is exposed to those negative prices. It doesn't have a counter hedge, and so when the prices are negative, they'll try to reduce their output onto the market to reduce that loss. Similar chart for the wind farms. And again, curtailment, not too big a number, which is great. And the offloading also not too big a number, which is nice to see that number not increasing too much. And the net increase from wind farms also around 400 megawatts. So that's the average for the whole of the 90 days of the quarter. Nice sign of new wind farms coming in. And this just looks at those numbers and going back all the way back to Q2 of 2021. And this is the curtailments. It's nice to see the curtailments being fairly low, as I indicated. So only about 60 megawatts average of curtailments to the solar and wind farms. And you'll see that most of it has actually been to the wind side. But it's nice to see that that's quite a bit lower than the last couple of quarters. But as you'll see from the Q2 2022, and then going back another year, given that that quarter wasn't very representative of a lot of things, again, going back to Q2 of 2021 as well, the numbers were very similar for that quarter. The other thing people watch is what was the highest amount of renewable energy in the NEM. And so it actually was higher back in Q4 of 2022 as we were getting the sunnier periods approaching summer of 2022. So it's still a little bit lower at the moment, but it did increase over the quarter 1 year ago. So it jumped up quite a lot by about 8%. From 58% to 66% in just 1 year. So again, another good sign of that increasing, and something that no doubt AEMO watches a little bit nervously as they develop all the tools they need to be able to manage these periods, short periods at the moment, but periods of very high percentage of renewable energy in the NEM. And this chart looks at ignoring PV rooftop, just looks at PV grid and wind and adds the two together. And what's nice to see is that adding those two together, the average, again, over the 90 days, is we've gone over the 10,000 megawatt mark. So over 10 gigawatt average on the grid coming from grid solar and grid wind power stations. So another nice number that we've passed through, which is nice to see. This one is a little disappointing, I think, but nonetheless, what it's showing us is as we're increasing the percentage of renewables on the NEM, then the NEM electricity-related carbon emissions are falling. It's unfortunate, though, probably, that in 11 years, we've dropped only from 0.88 down to 0.6 tonnes, so about 1/3 over that 11 years. It's great that it's continuing to go down. It's probably disappointing to a lot of people that it's not going down faster than that, but an important measurable for us to keep an eye on, particularly because, of course, the electricity emissions are only in themselves a percentage of all of the carbon emissions for Australia. Battery revenue is something that AEMO reports on, which is handy to watch. And this is looking at the revenue that a battery, again, based on NEM spot prices. So this is ignoring the hedges and other contracts that these batteries have. So it's not exactly what they earn, but it gives us an indication of what they're probably earning. And so Q2 2023 is lower than Q2 of 2022, as you would expect, because that was a troubled quarter. Batteries earned more money than they would normally do so it was expected that it would be lower. Interestingly, though, the big increase last year, of course, was in energy, by providing energy during that period. That's fallen down, so the energy prices are lower, so the energy component is smaller. But the other interesting thing is the batteries made more money in this quarter from selling energy than they did from their contingency. So either the regulation and regulation FCAS and contingency FCAS, that's the smaller amounts on the top here. The batteries actually made more money by actually just selling electricity, charging up which is the cost down the bottom, and then discharging at a higher price. So arbitrage, as it's usually called. This looks at a similar chart, but for pumped hydro, to see how pumped hydro is operating in the NEM. Again, quarter 2 last year, not very representative, and you'll see that the figures for quarter 2 2023 are pretty well on trend with what pumped hydro has been earning in the other quarters. Once again, the biggest item in there is the actual energy sales, not the FCAS income. This is a new performance measurable, which AEMO is putting in the quarterly report. This is the first time. And this is looking at the applications that they're processing and the projects that are getting registration and in commissioning. So AEMO's faced a fair bit of criticism in some of the energy conferences about the connections process and how difficult and slow they can be. They are complex, and the grid itself is complex. But it's good that AEMO is now putting this out there as a public set of numbers so we can actually see what's happening. What is nice is to see that in the last quarter, had 14 gigawatts of applications. And so, of course, the applications of that quarter are the projects that we hope to see actually reach financial close after getting their applications approved, and the ones that we hope to see over here in the not too distant future. Hope to see gigawatts of projects actually being commissioned rather than just being in application. And again, applications approved, a large increase in the connection applications that have been approved. So again, that's good. See 7 gigawatts of applications approved here. Again, another nice sign. And what we want to see is in a few quarters, these big numbers over here, turning up over here in the commissioning completed item. This chart gives us an idea of what the interflows were over the quarter from one region to another. And as has been typical for a while now, what this is telling us is that Queensland tends to send on average about 300 megawatts to New South Wales, and Victoria does also tend to send about 300 megawatts, 300 to 400 megawatts on average to New South Wales. That helps explain why the New South Wales government is incredibly active at the moment about facilitating its renewable energy zones, and of course has gone out to tender this year for firm renewable generation and long duration energy storage. So New South Wales is aware that it has been quite a bit dependent on the other states, and it doesn't want to maintain that. It wants to be independent on its most of its energy supply going forward, and that explains some of their drive. As has been the case for a little while now, Victoria tends to be a net exporter to South Australia. That's swapped around over the last couple of years. So about 100 megawatts on average going to South Australia from Victoria. And Tasmania, in a normal period, it's the yellow dot, which is the final amount, very small. So the supply between Victoria and Tasmania tends to be reasonably balanced, with sort of 200 megawatts going one way some of the time, 100 or 200 megawatts going the other way some of the time. But the actual net average is only about 50 megawatts going from Tasmania to Victoria there. FCAS costs, which end up in our electricity prices, of course. Nice to see them back down to a fairly low level of around $40 million for the quarter. Again, last year, not a representative quarter. The significant drop from 2021 is we're seeing more players in that FCAS market, and that's more competition is tending to drive to lower prices. If you actually look at the physical amount of FCAS contracts that AEMO settles, they haven't increased very much, but there's a lot of extra storage in the market that is providing FCAS services, So it's got more competitive, and so, as you would expect, the prices have dropped, which is nice to see. And this is a really good picture to demonstrate that. Batteries now taking 40% of the FCAS market share in terms of dollars. So very significant. A lot of that taken away from hydro and black coal. And so batteries are taking more and more of that FCAS work and income as more and more batteries enter the market. This also shows you the change that's occurred in the last year. So whereas a year ago, black coal had a significant amount of the contingency raise, which is where a lot of the dollars tend to be in the FCAS market, particularly in the 6-second and 60-second contingency raise. That 100 megawatts of extra market share on average that batteries have got in that FCAS contingency raise area has been taken away from the black coal providers of that FCAS. So that's probably a trend we'll see more of. The quarterly dynamics report also includes reports on gas, and it also reports on gas and electricity in the source in Western Australia as well. I don't normally look at this bit in much detail, but what I thought was interesting was this diagram, which shows the impact of the operational demand. That's the operational demand that AEMO sees in front of the meter when they had a solar eclipse earlier this year, which was fairly well covered in the media. So the duck curve, which normally would have gone like that, of course, with the solar in the middle of the day, got to this point, and then the solar eclipse started, and the solar output reduced significantly, both behind the meter and grid solar projects. And so the operational demand that AEMO saw went back up to 2,000 megawatts instead of being down at 1,000 megawatts, as would normally be the case in the middle of the day. So a really interesting chart mapping that outcome of what happened. And I'm sure there'll be a lot of data analysis of that by AEMO, looking at the NEM and future solar eclipses that will occur over in the NEM area. So that's it. Thank you for hanging in if you've got to this point, to the end of the presentation. And I hope it was useful. I hope it helped you and saved you perhaps some time in reading the whole of the quarterly dynamics report yourself. And thank you for listening.